In this video, I'm going to be solving the counting kitten problem, and with this one, I will try to make clear the difference between what is probability and what are the odds. Where do we use each one of these concepts and what is the difference between them? So first, the definitions. Probability is just a ratio, a division that measures the number of successful outcomes against all possible outcomes. So you have to count the number of successful outcomes, you have to count the number of possible outcomes, and you have to divide each number. And you get a probability with that. The odds are a different ratio. They're the ratio of successful outcomes measured against the number of not successful outcomes. Okay, so in each case, you just need to count things, successful outcomes, possible outcomes, or not successful outcomes, and put them in these different ratios and get the division done. Okay, so now for the problem. You have 7 kittens in the litter and you have two different kinds. One kind has stripes, the other one does not. And you're told that you're choosing 3 kittens at random and you have to find the odds for different events. The first of which is this one. All 3 kittens that you have chosen have stripes. So how do you find the odds of this? And first, it's convenient for any problem to figure what the situation is, to think about the situation. And in this case, we have 7 kittens, so here they are. 1, 2, 3, 4, 5, 6, 7. 7 kittens of two different kinds. One kind has stripes, the other one does not. But is this actually the scenario we have? It is not, because we have two different kinds, but we can distinguish between all the kittens. It's not going to be the same which one we choose. So it's better, it's more useful if we think about the scenario something like this, that we have two different kinds, that we have a way to distinguish between all 7 kittens and between all 4 that are striped and all 3 that are not striped. Okay, so this is more or less what we have. We can distinguish the kittens, and when choosing the 3, the order is it's not gonna matter, because we're just trying to find scenarios in which we have chosen different kittens or not, and we're not that interested in which order we have to pick them. And that is just a scenario in which the counting is going to involve combinations. So now we have established that out of the 7 kittens, whatever count we need to do, it's going to be a combination. Back to the problem and back to the definitions. If you see the definitions, probability and for probability and for the odds, you need to count the number of successful outcomes, the number of all possible outcomes, and the number of not successful outcomes. So I'm going to leave the things you need to count here. And instead of thinking about just the odds right now, let's think about the probability. It's easier to always start thinking about probabilities than odds. Odds are kind of a weird way to present the information. So probability needs the number of successful outcomes and the number of all possible outcomes. So let's think about these questions. How do we count these things, and what does it mean to count these things for this problem of all 3 kittens having stripes? So the first thing is, in how many ways can we choose 3 kittens from the 7? Remember that we said that this was a problem of combinations. So this is the way to choose them. Just picking 3 out of 7, the order does not matter. So it's 7C3. Combinations of 3 kittens out of the 7. And the number, you work it out, it's 35. These are all the possible outcomes. So we have established now that no matter what these scenarios are, there are only 35 possible outcomes. There are only 35 different ways in which we can choose the 3 kittens. Now we just need to know how many ways do we have for the different scenarios that we're presented. So how many ways to choose 3 striped kittens from the 4 because we're interested in the striped ones. And again, this is a combination, but now the numbers change because we now have 4 to choose from and we want to choose 3. So it's 4C3, and these are the successful outcomes for this problem, for the all 3 have stripes. What is the probability then? The division of the successful outcomes of these ones divided by the number of all possible outcomes. So it's 4 out of 35. That's a probability, but we have also found with this, well, successful outcomes and all possible outcomes. So I'll leave them here. And also, if you know that all possible outcomes are 35, the successful outcomes are 4, then the number of not successful outcomes is going to be 31. There's no other way to count the not successful ones. I'm going to leave them here. I'm going to leave these numbers here. And now let's go back to the original problem and find the odds. Remember that the odds are the number of successful outcomes measured against the number of not successful outcomes. So this is going to be simply 4 over 31. We usually say that the odds are 4 to 31. We don't present fraction. And if you try to simplify this, you get that the odds are about 1 to 8. This is the most usual way in which odds are presented, and it shouldn't be confused with the probability. We just calculated that the probability was 4 out of 35. The probability is around 11.4%. There is a probability of 11% that we have this scenario, that all 3 that we have chosen, that we have randomly chosen, have stripes. And the odds, if you are to think about the odds in percentage, this is 12.9, it's almost 13%. The odds are bigger than the actual probability. So the odds are always going to be like that, bigger than the actual probability. Don't get fooled by that. Odds are a different way to present the information. Odds are a completely different thing. The odds are just how more likely one thing, one scenario is than the other one. So this one, 1 to 8, means that getting all 3 kittens is about 1/8 likely, that it's about 8 times more likely to not get this than to get it. That's what the odds mean, but that is different than the probability, so don't get confused with that, don't get fooled by that. Let's analyze the second problem. The second scenario has that out of the 3 kittens that are picked at random, what are the odds that only one has stripes? So we have already established this, all possible outcomes of 35. And now let's count the successful outcomes and find the not successful ones. Only one has stripes translates into this. If we are choosing only one striped cat, then we are also choosing 2 that are not striped. And this might seem silly because it's rephrasing this thing, but it's going to prove key to finding the answer because everything is in here. Choosing 1 striped cat and choosing 2 that are not striped. How do you choose 1 striped cat? Well, again, problem of combinations, 4 different options because 4 different kittens have stripes and you just have to choose 1. So it's 4C1 and this number is 4. And for the other one, how do you choose 2 that are not striped? Well, you have 3 different options for this one because there are 3 kittens that are not striped and you have to choose 2. That number is 3C2, that is 3. And applying the fundamental counting principle, the total number of options that you have in choosing 1 striped and 2 that are not striped comes by multiplying these 2 outcomes. So it's just going to be 12, 4 times 3. And this is the number of successful outcomes. If 12 is this number, this one is what's left to make for the 35 total possible outcomes. So this is 23, and then the odds are just 12 over 23, or we can say that the odds are 12 to 23, or about 1 to 2. And again, this number is around 52%, which is very different than the probability, which is 34%. And again, you can see here, saying that the odds are about 1 to 2 means that not having this scenario happening is twice as likely as having this one happening. That's the interpretation of this thing when you say that the odds are about 1 to 2, which again shouldn't be confused to the probability. To my liking, speaking about the odds is just a way to fool people into gambling and into gambling more. But anyways, now you know, don't get fooled by this. And the last scenario, only one that is not striped. Find the odds that one of the kittens is not striped. So again, we're choosing only one not striped cat, and we're choosing two that are striped. The ways to choose one striped cat are these ones. Remember, we have 3 to choose from. We want to choose one. This is the number. And choosing 2 that are striped, we have 4 to choose from. We're choosing 2. This is the number 4C2. And by the fundamental counting principle again, the total number of successful outcomes is 18. I'll leave it here, and therefore the number of not successful outcomes is 17. So the odds can be calculated as 18 over 17. This number is even bigger than 1. With probability, you never have this. And in here you say odds are 18 to 17, or about the same, right? And about the same means that it's equally likely to have this scenario than not to have it. The probability, though, is 51%. This is slightly more likely to have this scenario than not to have it, but it's more or less the same. So again, do not be fooled by this. You just have 1 in 2 chances of winning it, 1/2, and it's not the same as the odds.